Hello everyone. Today I am going to explain about materials and their properties. So, the physical property of a material denotes the physical state without changing the chemical or mechanical components. So, these physical properties includes texture, density, mass, melting point and boiling point, etc. So, strength of materials. So, this term is also called as mechanics of materials. So, this subject mainly mechanics of materials mainly deals with the behavior of solid subjected to stress and strain. So, some of the important properties of materials are shown in this diagram. So, let us discuss one by one. So, first, strength. So, strength is the ability of a material to withstand external loads without failure. So, a stronger material can carry more load without breaking. Okay, strength is another way to determine the ability of a material to withstand stress without failure. Strength tells us how much stress a material can handle before it fails. Then elasticity. So, elasticity is a property of a material which it returns to its original shape after the removal of load. So, when a material is stretched or compressed and then comes back to its original position after the removal of load, that property is called elasticity. Okay, this elasticity is mainly present in springs, rubber band, and structural component. Okay, then rigid body. Rigid body is defined as the body where the distance between 2 points never change whatever the force is applied. So, practically there is no rigid body. Then deformable body. So, this deformable body is opposite to rigid body. So, when we apply stress in this body, the distance between 2 points change. Okay, so the study of properties of this deformable body is called elasticity. Okay, so let's consider stress strain curve. So here yield point present. So at this yield point we are able to see 4 main points. So let us discuss one by one what are the points present on this region. Okay, so the first point is proportional limit. So the proportional limit is the maximum stress up to which the strain and the stress are directly proportional. So this means the material follows Hooke's law under this region. Okay, okay. And elastic limit. Elastic limit is a maximum stress that a material can withstand without permanent deformation. So if the stress goes beyond this limit, the material will do not return to its original shape, then the permanent deformation starts to occur. Okay, the permanent deformation will starts to occur. So this point is called elastic limit. Then yield point. So at a certain point, ductile material stop to offering resistance to tensile force. So at this stage, large deformation occurs with little or no increase in stress. So mild steel is the example for this phenomena. Then proof stress. So some materials do not show a clear yield point. For such materials, we have to use proof stress to calculate the stress. Okay, proof stress is a stress at which a small permanent deformation occurs. To find out the proof stress, so this is our stress strain diagram. So we consider 0.2% of strain here, and we have to draw a linear line parallel to elastic region, and the point at which this proof stress line intersect this stress strain curve is considered as the proof stress point. Okay, this property is only applicable for such materials do not show clear yield point. Okay, then stiffness. So stiffness is the resistance of a material to elastic deformation. Okay, if the material shows very small deformation under load, it is called stiff. So stiffness is mainly depend on Young's modulus. Young's modulus value is high, then the stiffness of the material is also high. Okay, and then Plasticity. So plasticity is the ability of a material to undergo permanent deformation without breaking. So plastic deformation occurs after the elastic limit crossed. Okay. Then ductility. So ductility is the ability of a material to drawn into thin wires. Okay. So mild steel is a ductile material. So ductility is measured by percentage elongation and reduction in area during tensile testing. So materials with high ductility can undergo large deformation before breaking. Then malleability. So malleability is the ability of a material to be hammered or rolled into thin sheets without cracking. So aluminum and copper lead are the example for malleable material. So this malleability property is very useful in steel metal industries. Then resilience. So resilience is the ability of a material to absorb energy within the elastic limit. Within the elastic limit only. Okay. And the maximum energy stored within the elastic limit is called proof resilience. Okay. Then toughness. So toughness is the ability of a material to absorb energy before fracture. So this includes both. For example, mild steel is tougher than glass because it can absorb more energy before breaking. It includes both elastic and plastic deformation. So tough materials are used in structural and machine operation. So for example, manganese steel, Rockdon and mild steel are the example for toughness material. Okay. Then hardness. So hardness is a fundamental property which is closely related to strength. So, it is defined as the ability of a material to resist scratching, cutting, abrasion, and penetration. So, there are three main methods which determines hardness, which is Rockwell, Brinell, and Vickers. Okay. So, hardness is not directly related to hardenability. Then, brittleness. So, brittleness is the property of breaking without much permanent deformation. So, brittle materials are break suddenly. Okay. So examples for brittle materials are glass and cast iron. Then creep. So creep is a slow and continuous deformation of a material under constant stress over a long time. So it mostly occurs at high temperature. It's a time dependent process. Okay, metal shows creep at high temperature while plastics and rubbers are more temperature sensitive. uh, So creep is considered to be important in turbines, boilers, and high temperature applications. Okay. Then machinability. So machinability is the ease with which a material can be machined. Okay. If a material can be cut easily with good surface finish and less tool wear, it has a good machinability. So good machinability, in fact, implies satisfactory result in machining. So the machinability is indicated by percentage on which termed as machinability index. Okay. So mm, the machinability index of carbon varies. Steel or 40 to 60 percentage, and cast iron is from 50 to 80 percentage. Then fatigue. So fatigue is a failure of material due to repeated or cyclic loading. Even if the stress is within elastic limit, repeated loading can cause failure over time. So fatigue is very important in rotating shaft, bridges, aircraft parts, and machining operation. So it's a cyclic load application in elastic range. So elastic limit. So whenever some external system of force act on a body, it undergoes some deformation. If the force is removed and the material returns to its original shape, it is within elastic limit. So beyond the elastic limit, permanent deformation occurs and the material enters to plastic stage. Okay. So the value of stress correspond to the force is called elastic limit of a material. So in conclusion, Understanding materials properties such as strength, elasticity, stiffness, plasticity, ductility, hardness, toughness, fatigue, creep, and machinability is very important in engineering. These properties help engineers select the right material for the right applications. So my next topic is ASTM standards. So ASTM stands for American Society for Testing Materials. So now it is known as ASTM International. So it is now in this presentation I will explain what ASTM standards are and why they are important and where they are used in engineering. So the purpose of these ASTM standards are to ensure quality and safety, and it gives the proper rules and guidance for testing materials, products, and test systems. So it was founded in 1898 and today it is recognized worldwide. So many industries follows ASTM standards to maintain quality and safety. And so these are many ASTM standards are used in engineering. So for example, ASTM 36 is used for structural steel. So ASTM E8 which is used for tensile testing of materials. So ASTM D638 tensile testing of plastics. So these standards clearly explain specimens dimension, testing procedure and calculation method. So as a metallurgical student, ASTM E8 is a very important one because it is related to tensile testing. Then importance for engineers. So ASTM standards helps engineers in selecting proper material and they ensure product reliability and performance. So they are required for quality control and certification in industries. Okay. So in conclusion, to conclude, ASTM standards provides globally accepted guidance for testing and materials. So they improve safety, performance, and consistency in engineering applications. So without standards, maintain uniform quality would be very difficult. So ASTM plays a very important role in engineering and manufacturing industries. So thank you.